Hi, everyone. Welcome to the Launch Space. My name is Jason Hand. I'm filling in for Brian Benz this week. Really excited to be here today. It's going to be another fun episode. I'm excited to be back on Learn TV talking to you all. Today, we've got our friends from Azure Web PubSub Service, or PubSub Service, who's going to be showing us some really cool demos and showing off a lot of the things that they've been doing recently. Make sure you join in the conversation. If you're joining us from wherever you are, come over to Learn TV. We'd love to have you be part of that conversation there. We've got chat set up. We'll do our best to answer any of the questions you might have. And also make sure you tune into the show notes page. If you want to check out what's going on after we're all done, we'll have all the notes and everything else there. You can find that at aka.ms/thelaunchspace. We've also got a link for you that'll take you straight to just today's information. If you want to check that out too, that's aka.ms/thelaunchspace PubSub. All right, well, that's a little bit of a tongue twister for me, but let's go ahead and bring in our guests. All right, we got two really great specialists from the team who's going to be talking to us today. Say hello to our good friends, Liangying Wei and Yulin Shi. Hi, friends.
Hey, everybody. Hello. Hey, how are you?
Hey, thanks for joining us today on the Launch Space. Really excited to have you. I've been looking forward to doing this for a long time. So, Yulin, why don't you tell us a little bit about Web PubSub and what we're going to be talking about today?
Basically, my name is Yulin. Hi, everybody. My name is Yulin. I'm the product manager for the Azure Web PubSub. It's a new service we introduced to the market this year. And PubSub, basically, you only need to remember one statement. If you ever need push data in real time, that's what PubSub do, right? Then today we will actually go through a few introductions on what is PubSub, what are the scenarios we're using it, and how to use it. Then Liangying, our senior developer in here, will jump into the demo, show you guys how to do the coding and how the demo works.
Excellent. Well, I know we've got some stuff that you're going to share for us. So if you've got a screen you want to pull it for us here, we can start diving into, give us a little bit more detail on what the service does, what it's used for, and what's coming down the road for us.
Yes, correct. Yeah, let's move to the next page. Yeah, as everybody can know, in the real time, we have a lot of scenarios, and we will do the messaging between each other, between the client and servers, between the client devices as well. For instance, like co-authoring, multiple people are working on the same document, like real-time location-based trackings. Like when a UPS guy is coming through his station to my home, we will know on the map where he is really at right now. Then a lot of us have the experience when we play the game or something, we see some app notifications, push us a coupon, advertisement, all those type of things. Not to mention, there's another big scenario is we call it the live dashboard. Like we only have the stock market exchange market in there with stock value changes. It will automatically update our application in there. Another thing is like we have a lot of like IoT devices, and the management team or maintenance team will know all the current situations of the devices. They will have a live dashboard. The dashboard will actually show you guys the status on the real time. Okay. Let's move to the next one. Yeah, just stop me with any questions you have, Jason. There. Thank you.
No, I was just going to comment that I love the focus on this. But, fast feedback is always what we're after, and it seems like these days all the applications we're using, they're generating data, whether that's IoT devices or whatever it is, and getting that fast feedback or communicating that information as quickly as possible. I think the real time part is really the key to this service, right?
Yeah, exactly. Real time is all we talk about. And then people will come out, why are we need to use AWPS, we shorted for the Azure Web PubSub. So basically 3 words in there. First, real time, just like you mentioned, real time everything, we push data over. Then the second part is we are cloud managed service. And as you know, we have a big Azure as our backbone, and it gave us a large scale of client connections, and we have the high available architecture in there. And users, you will have that peace in mind. As many as connections you want to be, we can handle it. So the third one basically is like since we are in a mobile world right now, and we have a lot of devices or clients on different formats. Like we have desktop, we have browsers, we have mobile. We support all of those. And we are all developers. Developer basically do like somebody use Java, somebody use Python. We are C#, of course, but we support everything, JavaScript, everything. So we have a rich client support.
That's great.
Then basically, this is actually out of my reach, but I will give you guys a short introduction in here. The page we showed here is basically we transition from the classic structure. They have clients, a bunch of clients. They have a web server. They connect to each other, communicate to each other, send data, send messages. In the past, that's the traditional way. Then we bring up the middle one, the big bubble in there, the Azure Web PubSub Service. The service itself, from the backbone, will connect to your app server. Then from front end, it connects or manages all the connections from your clients, all the clients, mobile, desktop, browsers, and using the standard WebSockets. So that basically means you can scale out with as many clients as you guys want to have. And we have some big customers, there's like millions of clients devices connecting through our service right now. So
Okay.
can you go to the next page,
And I imagine that scalability, where the cloud is in that image, that's where all the complicated stuff happens. That's where we're taking that off the developer's plate, so they don't have to worry about all these different connections and what's being passed. And so that helps with the scalability, right?
Exactly. And there's one like a serverless, we call it serverless situation. Basically, in a lot of situations, you may have one client want to send message to another client. In that case, you don't even need to go back to your app server. Just go through our service. Every client could become a publisher. Another client could become a subscriber. It will receive the message. Then in this case, you get a lightweight round trip between them. Then everything just works. All right.
I like it.
Okay, next one. Yeah, so we already talked about this. From the back end, we have the server SDK for a lot of programming languages. Your app server actually implement this and put everything into the app server logics and then connect to our services there, PubSub service. From client side, one single statement basically in there, all the environments you have. So all the programming language you're using, all different devices, IoT, mobile, desktop, browser, everything. Okay.
Excellent. You got them all covered.
You all covered. Yeah. Everybody needs to be connected, right?
Exactly right. Like you show up with what you use and the language you like to work in, and it just works.
Yes. Then the next one, please. Yep. So this is a big chart. A lot of things. You guys want to take a screenshot or whatever, just in case I give you the scenarios on the industry in there. But all you need to remember, just in the very middle of that circle, we push data in real time. That's it. Whenever you have a situation, scenario, want to push data in real time to your clients, to your devices, that's us.
Right. And then more and more, that's kind of everybody's goal is we got to get that data pushed out to our users, give them that feedback as fast as we can.
Yep, exactly. So let's basically, I'm the program manager here, so you guys are all the developers, so you don't want to hear me blah, 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 blah again. So let me bring up our senior dev, Liangying, and she will be showing us the code, showing us the demo. Thank you.
All right, thank you, Yulin.
Thank you, Yulin. So I will start with the demos. First, I will show you this Web PubSub service I just created. So you can create this from the portal, or you can create this through the Azure CLI. So in this overview page, you'll get some summaries of this service. And I'd like to show you this keys settings page, which contains the connection string that we usually use this connection string to sign a token to connect to the service. So for Web PubSub service, we leverage the JSON Web Token, aka JWT token authentication to connect to the service. So every client, every request, we need to use this JWT token in the query string or in the authorization header to talk to the service. But don't worry about how to sign this from connection string, because we provide SDKs for you to do so. Also in the portal, we have this client URL generator, which would help you to generate a temporarily available client access URL for you to do some quick test using the WebSocket APIs to connect to the service quickly. You can see that here we have a hub. This is a concept in Web PubSub Service. This is a required field, so which means that the WebSocket clients, every WebSocket client needs to connect to a hub when it starts to connect to the service. Hub is a logic concept, a logic isolation for the clients. Clients within a hub can talk to each other, and only when they are within the same hub, they can talk to each other. So we usually use different hubs for different purpose. For example, a chat hub, a notification hub, or some dashboard hub. Today, I'm not going to use this client access URL for our demo, but if you want to try for yourself, you can go to the overview page and click this quick try. And in this quick try, we have this very simple sample to show how the Web PubSub service works, and you can paste the client access URL here and just click connect, and you can try this demo. So today I'm going to show a chat demo. So this is a super simple chat demo, but don't worry, step by step, I will change this to a little bit fancy one with more features added to this sample. So first, let's see how the chat works. This is Liangying here. I joined the chat, and this is I have Yulin to join the chat too. So I type greetings, Yulin. Yeah, but you can see that both chat received this message, and for Yulin, he can say hi. Yeah, so this just works. This is a chat that both clients receive the messages immediately after the other chat send some messages. So how this works? Let's see how the client works first. So the client is actually have little code here. It actually has two steps. The first step is to call the fetch URL to our app server, then negotiate to get the client access token, client access URL, which we mentioned before in the portal, that the portal helps us to generate. It called the SDK, the app server side, to get this URL for the client to connect. So when the URL is fetched, it just starts a WebSocket connection to the service. You see, there's no other packages or APIs required for you to connect to the service. You just use the browser-supported WebSocket API to connect. And then you add some event handler. For example, when the message comes, when the WebSocket message comes, we now just print this message into the browser web page. And we also add an event listener for keypress. That's when I type messages and I press enter, and this actually calls the WebSocket send API to send the messages out. So as we mentioned before, actually the Azure Web PubSub Service handles this WebSocket connections. So the app server, there's no need for this to be a WebSocket server. It just needs to be some regular HTTP server. So how does this work? I'd like to first give you a general overview of how this works. Previously, when we don't have the Web PubSub service, the client connect to the app server directly using WebSocket connections. So app server need to handle this persistent connection by itself. For example, when we upgrade the app servers, when we take down the instances one by one, for example, when we take down the instance one, all the connections connected to the instance one would be dropped because this is a persistent connection. So with the help of the Azure Web PubSub service, the clients
Liangying? Liangying, if you can hear me, I think we've lost your mic. Yeah, I think we've lost you. If maybe we could bring Yulin back on, if Yulin's still here with us. Yulin, are you there? Can you hear us?
Just come back. Sorry, I lost the connection.
Yeah, okay. I'm not sure if she's having a problem with her microphone. Liangying, can you hear us?
Liangying, we cannot hear you. Sorry about that. We cannot hear you.
These are always the trials and tribulations.
Yeah, that's the problem. We don't have those like good connection as you guys have there.
Exactly.
Yeah. Liangying, you may need to close your Teams on your desktop there. So no Teams.
Yeah. It might
maybe the microphone.
It could be, yeah, it could just be the microphone. I would say maybe coming in and out of our broadcast software might be the good thing to try. Well, Yulin, while we're waiting on Liangying to solve her microphone, what kinds of things? I know she's got a whole lot of demos still to get through. But what types of things are you and the team thinking about and working on for the future? I know there's some general available stuff coming up that we're going to get to, but yeah, what can you share with us, sort of long-term thinking about?
Basically, maybe we'll just take the chance to talk about the timelines here, right?
Sure,
so the PubSub at this moment is in the public review stage. So we have about like 700 customers online already on the service already. They have big scale, small scale, some free players in there. And we do have the back, Liangying.
Hello, can you hear me now?
Yeah, hey, we got audio again.
Oh,
right.
Let
me finish first. All right.
That's all right. That's great.
All right.
So where am I?
Yeah, we lost you there.
Getting a quick story from Yulin, but yeah, we can go back to your slides and we can show you where we lost audio and have you start back from there.
Where we lost the video.
Yeah,
you're talking about the communications from the clients to the server there.
Yeah, but you'll have to reshare. You'll have to go ahead and reshare your screen again, and we'll have our producers pull that up so we can.
It happens.
Where we left off. It happens all the time.
Yeah.
This is just the fun.
We really need those like satellite connections, right? So
we haven't been doing this show for a real long time, but we've been doing demos and talking in front of people and coaching and doing all that for a long time, and it never fails. There's always some kind of demo technical problems. So we just roll with it, and luckily our audience knows that that's how it goes too. So, but while we have everybody here too, I'm going to say just one more time because I put something in chat. Is if you got questions for any of us, really, make sure you join us over there. We've got probably plenty of time to get to the questions towards the end, even with this little bit of a technical problem here. So, Liang, you want to try to share your screen again, and we'll see if our producers can pull that up and get that looking good.
Sure. So, is this the one I start losing the audience?
We're not seeing your screen right now.
Yeah, you'll still need to hit the share thing at the bottom. Does that video have audio in it? Do we think that might have been when things went sideways?
Is this one?
Yeah, let's pull that. Let's have our producers pull that back in here, and we can.
Is that this slide?
Yes.
I think you were in there. Yes, I think that's about the time the microphone cut out.
Okay, I'm sorry.
Yeah. No, that's all great. Yulin and I will drop off, and we'll let you take it from here. And yeah.
Yeah, thank you. So then the Azure Web PubSub Service sits in the middle so that it helps to handle the WebSocket connections between the client and the service. And then the Azure Web PubSub transforms the events to the upstream, to the app server side using HTTP post. And in return, the app server just invoke the Azure Web PubSub Service using the REST API HTTP calls or the SDKs we provided. Service helps us to deliver these messages through the WebSocket connections to the clients. So in this way, the app servers only need to handle the events when it needs to, and it can focus on the application logic. Let's see what happens when the client establishes a WebSocket connection when it uses new WebSocket API. So when this new WebSocket API is created, that's actually the first thing is to have a WebSocket handshake with the service. When this happens, the service can trigger a connect event to the server so that the server can interrupt with this handshake and, for example, return some sub-protocol to the client to establish this WebSocket connection. So when this WebSocket connection is successfully established, it triggers a connected event, which is async, which means the service does not expect the response from the server. It will continuously process the other incoming events. So then the client send messages. Client can keep sending messages, and for the messages, client send the service just to trigger a message event to the server. So it can send many messages. At last, when the WebSocket connection is closed, the service will trigger a disconnected event to the server. So these events disconnected, these are related to the lifetime of the connection. For this, we call them system events. And for the message event, we call them user events. So how the service knows which endpoint it should trigger the events. So which endpoint the service would post the cloud events request to. So there are two things to do. The first thing is that the server needs to expose an endpoint for the service to call. And another thing is that we need to tell the service that when what event comes, which endpoint it wants to send the cloud events to. It is kind of similar to the webhook settings. So go back to our demo. So in our demo, this you can see that this actually is app server hosting in localhost. So how can the Web PubSub service know localhost? We actually use this Ngrok tool to expose the local endpoint to public. So actually, the service actually knows that this localhost redirects this traffic to localhost using Ngrok's help. You can see that during our chat demo, actually, the localhost receives these post requests from the upstream, from the service, sorry. The other thing is to register these event handlers in our Web PubSub service, which can be set from the settings page. And as you can see, I already registered one. This is the Ngrok page, so that's why the chat works. Okay. So this is this simple demo, and after we set these settings in the service, let's take a look at the server-side code that does not contain the WebSocket server, but it contains the Web PubSub middleware. So first, this server side, this uses this Express to handle these web pages. The static web pages, it have to serve this. And then it handles the negotiate endpoint, right? To provide the clients the get client access URL for the clients. You can see that we use this package provided by the Web PubSub service, and you can simply call this get authentication token to get the URL for the clients. We provide SDKs in 4 languages for you, like Java, JavaScript, C#, and Python. So you don't need to do this manually by your own. The next thing is the middleware to handle the incoming cloud events requests. There are 2 things we set. The first thing is the path, which is used to expose the endpoint that processes the cloud events request. The other one is the handle user event callback. This one is triggered when every time the message comes in from the service to the server. So here, when a message comes in, we call our SDK to help send the messages to all the connected clients, to broadcast the messages to the connected clients. And with some metadata, for example, where this is from. Yeah, this is the middleware, and then that's how the chat demo works. Okay, so the benefits of using this architecture is that actually we can stop the server, we can upgrade the server in real time, because the service connection handles because the service handles this persistent connection. When the server is pulled down, there's no impact to the client because the client is still connected to the service. So one thing is that when client send messages to the service and then to the server, message 1 could go to server instance 1, message 2 could go to server instance 2, and server message 3 could go to server instance 3. But what if we have messages, they have states that should be that message 2 processor depends on? We have a very interesting feature called the connection state, which can be used to store the some metadata for the connection during the lifetime of the connection. So the message 1, for example, it sets some state to the connection. Then message 2, the processor of message 2 and message 3 can get this state or get some update to the state, and the following processors can get that state, and this can be kind of helpful. And let's see if we how we add, for example, in this demo we can add a message count using this state, so that we can say how many messages are sent, are received for this connection. Let's try this this feature. For example, we say message count. We get the states from the count state, and if it does not exist, it means there's no messages. This is the first message, and then we increase this one because we already have this message, and then we set this state back to this count key. Also, when we broadcast, we add this count, this ID, to the message. Okay, we have this updated code, and we just stop this server and restart. Let's try the chat. Let's see what happens. Oh, oops. Just have a typo. So you can see that we can restart the server for several times, but the clients are not. Maybe it's impacted because the server throws. Let me refresh this one. You can see that the message is successfully broadcasted. Should be like this. Try this again. Okay, you can see that the logic is updated in real time. So every connection has a message ID. Okay, let's go back to the introduction. So you can see that this one actually does not require states handled in the server side. So which means that the server can be stateless. This is quite similar to the serverless case, right? So actually, we also have extensions in Azure for Azure functions, so that we can develop the serverless applications easily integrating with our service. Let's see how we can achieve the same chat app using the Azure Function extensions. What is the Azure Function development experiences? Okay, so you can see that this is a Azure Function app. Azure Function app, I already created the serverless chat. So basically, it has 3 functions. The first one is similar to which we showed before when we self-host the app server. Which, this is the one to get the web pages when using HTTP trigger. Another one is, again, as similar to the app server. We just wrote the negotiate, which the client uses to negotiate with this one and get back the client access URL containing this access token to connect. So you can see that different. This is a little different than the when we write this in our app server. We actually provided one web PubSub connection input binding, so that it helps you to generate the access token and the URL inside. So actually, you don't need to do anything. You just return this connection. Then it helps you to generate the URL for your client. And also here's the message function that it is triggered when every message call comes in. That we have this WebSocket web PubSub trigger that triggers automatically when this message comes in and transforms the cloud events data into process this cloud events data into messages and some necessary metadata inside the connection. Also, we have this web PubSub output trigger that you can use to send the data back to the clients. So you can see that this is comparatively simpler than when we write our own app server. This is so for example, you can see we add a send to all message to the operations so that it then can work. Let's start this function to see how this works. First, let's stop this previously self-host one, and we start this function. Takes some time to compile. Okay, so
Liangying, I've got a question while that's compiling. Oh, it looks like it's about done there. Yeah, I just wanted to stop and point out something, make sure I understood what I saw. You're now showing off a function, so we're going to sort of the serverless route. Previously, you were doing it in a Node.js method, but both of those times when you made changes or you started the function, you didn't have to do anything on the service side. You didn't restart any service or anything. You're just kind of re-kicking off your own code, right?
Yeah, correct. Because the service is still there alive, and the client connects to the service using the WebSocket connections. So the clients are still connected to the service.
Okay, yeah, that's brilliant. I just want to make sure I point that out because I think like that's a big part of the story is that you don't have to go back into the portal and restart any service or refresh anything or anything like that. You just restart your own app.
Yeah, correct. Thanks for pointing this out. Yeah.
And also, what did we do before ngrok? Isn't that just the greatest tool for developers now to be able to like make these little proxy connections into different services from the safety of our machines?
Oh, ngrok. Angrok
isn't that great?
Yeah, Angrok. Yeah.
What did we do for that?
This simply expose a public endpoint for
Mhm.
localhost.
Yeah.
So you know our service is online. With the help of Angrok, the service is able to find the localhost app server.
Right. Yep.
Mhm.
That's an awesome tool. Okay, I'll let you get back to the serverless part of the demo. Thanks.
Thanks for asking. So this function app is already up, and we can access the HTML from this one. Let's start another similar chart as before, but in this time, this is a serverless case. Yeah, so this works. Make sure this works bidirectionally. Yeah, both can chat to each other. So let's see. So we can see that in this local running function, we can see that the negotiate is triggered, the messages are triggered. So next thing, what we will do next? Well, as I mentioned before, we will make this this super simple chat to be a little more fancy. Let's see how this can be fancy with some little more CSS added. So one change is the WebSocket connection. This is now use a sub protocol. So as you might already know, WebSocket protocol, it also supports sub protocols, which can define the structure of the data coming inside the WebSocket frames, so that we can do more things to this WebSocket data frame. For Web PubSub service, it natively supports this sub protocol. What can this do? This can return more messages to the client when the client is successfully connected. We can see that in the when connect, the callback when it's connected, it can define if it can check if the response type is system. When this is system, it actually can contain some more metadata for the connection. For example, the user ID, the connection ID. So in this way, we can know that if the message is broadcasted is from myself or from others. So let's see how this fancy demo be fancy. We change this to fancy. Then we connect. So you can see that when this connects, it actually has this connection ID, which is unique to every connection and is automatically generated by the service. And we have this username Yuling, which is fetched out from the JWT token by the service. So this metadata is sent back to the client, and the client knows that my user ID and my connection ID. And when I say hello, the backend is not changed. So this is just the UI change. With the help of our sub protocol, we can get more metadata from the service side. And actually, the sub protocol can do more besides adding these metadata. I will talk to that later. So first, let's see. So this serverless case that we still have the app server side logic, the application logic to handle the incoming messages. But what if we don't want any app server side? We don't need any application logic. All the clients can determine when it wants to send data to others. We also provide this capability for the clients to directly talk to other clients with the help of this sub protocol. So let's see how this works, how this can work with the help of the sub protocol. since we use this JWT token, we still need the negotiate URL to provide the access token for the clients. In this time, we switch back to the Node.js app, but because we don't have the upstream need, we don't need the application logic, we just close this ngrok. And we remove this middleware because we don't need to handle any cloud events anymore. And I will start, it only provides the negotiate endpoint. And I start this server. And this server, I have this client PubSub HTML, which you can see that negotiate with the app server first, and then it connects to the service using WebSocket connection, and as well as the sub protocol we provided. And let's see how this works. Oops. So this is a client PubSub. Okay. I connect. Yeah, so I'm successfully connected, and I have a connection ID because I'm using the sub protocol. And I'm going to show you the network of this service. Oh, I need to connect again because the WebSocket, I need to capture this network, WebSocket network. So you can see that there's downstream message from the service telling us the connection ID, the event, and the username. And when I click this join, the client is actually sending this join group command to the service with an ACK ID. When you add the ACK ID to the message, which this means that you are expecting an ACK from the service. So the service will tell you if this action is successfully triggered or not. So here we see that this is not because we client needs permission to join the group for security sake, which we haven't granted the client to have this permission. So what we will do, we'll need to grant the permission to the client. Let's change the server side to do so. So when generate the client token, beside this user ID parameter, we have this roles. So we have to join the group 1, and we need to add the Web PubSub join leave group 1. And we also want to send messages to the group. So we also need to add this permission to send to group 1. Let's restart the server to see what happened. Okay, so let's try to connect once more. It closes the previous connection and start a new one. So we see that another connection comes. It's connected. I'm trying to join the group, sending the join group JSON. Okay, then we can see that this is successfully triggered. So I'm now inside the group 1, and I'm going to send hello world to this group. I should be able to receive this because I'm inside this group 1. Yes, we can see that the connection received this message. So you can see that when I click the send, I actually send out a JSON payload saying that I'm going to send to group 1 with this data, hello world. And I also receive this ACK message. Also, I received this message from the group. So you can see that with the help of the sub protocol, you can actually, for different clients, you can join different groups, and the clients inside one group can talk to each other directly with the help of the service without the round trip to the upstream to the server side. Yeah. So what can we do with this client PubSub, what we call client PubSub feature? without going to the upstream. This can be useful when we have to transfer data between the clients. Or we have a live demo here. This is called code streaming. I'd like to show you this interesting demo. This can be used when you want to interview someone, that someone is writing the code. And we can have another one, the interviewer. Oops, I'm going to have this side by side. The interviewer, if it click this this similar link, same link, it can see what the candidate is typing in real time. You can see I type word main, and you can see the interviewer can see this in real time. This is using the client web PubSub, so that the writer, what the interviewer is writing broadcast to the others in real time. Okay, so we also have some interesting demos, some other interesting demos like whiteboard, that we can use to draw and share the ideas to others in real time. Oh, we already have 6 person online. Oh, so many. And I can chat. This is also using the Web PubSub service, and we deliver this binary data in real time to the service and then to other clients. Yeah. So what else? So we also have this CLI that you can try by your own. We also provide client. You can also connect directly to the service through our Azure CLI. You can broadcast messages through CLI. You can even connect to the service using the CLI, because we provide this functionality. Under the hood, the CLI is actually using the Python SDK. So this can be helpful when you want to quick test your service and to play with this in a quick way. You can just try the cloud share, and you can just test the Web PubSub service in the web pages. Okay, I think that's all for my side for the demos.
Excellent. Well, thank you so much, Liangying. This is pretty amazing. I was like, my jaw was hitting the ground when you were showing the coding thing, and it shows up like in real time, just like it says when you're typing your code. Pretty fascinating stuff. Really good for like pair programming use cases and things like that. So thank you for all of that. We did have one question that came up over at Learn TV from Liangying, who wants to know when this is going to be ready for production use.
Oh.
Yeah, this
the question you can answer. Maybe you.
Please go ahead, Yuli.
Okay, I'll take that over. It's actually exactly the same question we talked about earlier. So basically, our service right now is in the public review stage, and we have a few hundred customers, internal, external customers, is using it, is testing it, play with it. And our current plan timeline for the GA is mid-November. So in another 2 months, you will see it in public. Everybody can use it, and you can sign up. You can do everything with it. And we do have 2 tiers at this moment. But it's a free tier. Free tier, basically, by the name, is free. So, but it does have some limitations. Like you only have like the 20 connections with 20,000 messages sent a day. So that's free tier, but it will be good enough for a lot of developers to play with it. Then after that, we actually have the mom is there. Yeah, that's fine. Yeah, we are at home. Then the standard tier is a little bit more powerful, and we have a bigger scale for everybody to use. It's actually enterprise ready for everybody. Okay. Yeah, in November, something you need to remember. Then we have a free playground in there. come join us.
Excellent. So, all right, yeah, get in there and play around with it now. It's free, more than you will need for a long time. Just just kind of playing around with it, and then it sounds like in November, we'll get more of an official launch for production use. Awesome. Cool. Well, one of the things that I was thinking about when we were watching those demos is there's a lot of, even in this model, there's still a lot of like handshakes and connections and things being passed across WebSockets. There's just a lot of activity, right? That's going back and forth. Even when you take out the server and you're just doing client to client, things are going in through the PubSub service, right? As someone when we're developing and we need to like get to the logs, I saw in what you were showing on the screen, obviously it comes back and shows you in VS Code what was executed and what happened and the timestamps. But is there another place? Is there some place for us to monitor all of the actions that are happening in the service itself while we're debugging, or maybe once we get to a production level and this is out there serving and being used by our users, how do we troubleshoot? How does an SRE, site reliability engineer, or anybody who's trying to solve a problem, how do they see all of the different things that are happening? Is that something we have available? Gillian?
Thanks for asking.
Yes, yeah, it's basically for debugging process. How do we do the debugging when a developer is trying to develop the application and run? Yeah.
Yeah, so when we GA, we are actively working on a feature to integrate with Azure Monitor. So when we GA, we integrated with the Azure Monitor, and we can dump the logs, incoming logs, to the Azure storage. So for now, we have this awesome live trace tool that you can monitor the incoming traffic in real time.
Excellent. Yeah, I think I saw something about that in the docs, which, by the way, there's a lot of great docs that answer some of these questions. There's questions about pricing. There's some get started tutorials. There's all kinds of really great stuff. And you can get to the docs, I think, through our show page. If you go to ak.ms/ the launch space PubSub, I believe you can jump over into docs and take a look at all of these resources that we've got available. That already there's so many great ones in here. Now, you showed off a little bit about the CLI. That was another thing I was really curious about. I was hoping that you would talk a little bit about that.
Sure.
What other, we didn't talk too much into specifics of what you can do with the CLI. But can you give us a little bit more information about what is available through the CLI?
Sure. Through the CLI, of course, we can create the instance and do some control plans things inside this Azure CLI. Besides that, we also have this cool client command, subcommand that you can directly connect to the service. So let's see. Let's try this.
Okay. You're gonna pull up your screen again? Yeah, let's do that.
You can see this.
Let's add your screen real quick here. Yeah, there we go.
Yes, we can.
So we have this demo to quick start connect to the Azure Web PubSub instance from CLI, and it has this control plan things that you can create the instance, you can update the properties, and we can play with the instance. We can just connect to the service from the CLI using the client sub command. So you can see that we have a command here. We just copy this. I replace this one with the instance I just created using some Chrome extension. So you might replace this with your own. So let me try this one. The Web PubSub extension is still in preview. But it has this cool sub commands for you to try. You can see that this already connected. From this, we know that actually this was the Python WebSocket API and connected to the service using our sub protocol because it has this more metadata provided. So we just join group.
And didn't you say earlier that under the hood, this is a Python SDK,
yeah, this is
right?
Yeah, this actually this is a client side, so it does not need the SDK. It just uses the Python WebSocket API.
Awesome.
Provided by the WebSocket package. Yeah. So I say I join group one, and it received seeing this success. And I'm going to send to group 1. You can see the usages above and say hello. Okay, you can see that it actually received this group message.
Very cool.
Mm-hmm.
Yeah, I can see a lot of people getting excited about that, making, creating some fancy bash scripts or something to get a lot of these things.
Besides that, besides connecting to this client, we can actually also access the server side to have this service commands that you can broadcast the messages to some hub. Let me try this one. Maybe I need to open 2 tabs so that I can see the messages coming in. But it's just a broadcast. Let me show what functionalities we have with this service subcommand.
Okay.
You can see that we can send to one specific connection. We can send to broadcast to a group. We can grant permissions to the client so that the client itself can join or send messages to groups. We can also send messages to the user. We can also broadcast to all the users. Yeah.
Excellent. Okay, some pretty powerful but basic but powerful stuff that's got available to us from in there. Okay.
Yeah,
so, thinking, I guess back to, because Liangying, when you were going through your demo, I could just tell, like, this stuff inside and out. You've probably worked with things like that. I'm guessing like SignalR. Obviously, there's a lot of like, comparisons to that. What was for you, Liangying, when you were working with this? What was there was probably a moment where you're like, oh, that is really, really cool. Like, that's just a little bit of an aha moment. So I'm curious if you could share with us, like, what is something that you feel you've come across that's really impressive about this service?
You mean Web PubSub?
Yeah.
So SignalR, I'd like to say SignalR first because I'm also working on SignalR service. And so SignalR is the one that we already have in C#. But then Web PubSub, the interesting part of Web PubSub is that this supports the WebSocket connections. So basically, it can used for various devices or clients that whenever it supports WebSocket connections, it can use our service. So for SignalR, we might have some client libraries for it to use the SignalR service. But for Web PubSub, you can start with a raw WebSocket API, so there's no need to have a client SDK to start with. So this makes the development very conveniently for those edge devices. Yeah.
Okay, excellent. Well, both of you, thank you so much for being here. We've got just about a minute left. I don't know if either one of you want to say any parting words, any last bits of information you'd like to share. Yunlin, you got anything for us?
Oh, yes. So basically, from my part, if you guys ever need just one statement to remember, push data in real time, that's us. Thanks, everybody.
That's real time. All right. And yeah. How about you? Any last words you want to share?
Thanks. So feel free to contact us if you have any future demand or if you have any suggestions or feedback to us. Just contact us through, we have a GitHub repo. Just contact us through this Azure Web PubSub GitHub and open issues to us. We really appreciate your feedback. Thanks.
Awesome. Yeah. And again, thank you so much for being here. I'm sure we'll add a bunch of links into the show notes, including how to get in touch with you. I know you're eager to get people using the service and try it out and, learn from each other and see what we can do to impress or to move things forward and keep building impressive stuff, I guess you'd say. So again, thank you so much. And thanks to our producers and everybody backstage helping out with chat. It's been a pleasure. And this is the Launch Space. We'll see you next time. Thanks.
Thanks, Jason.